Hey, it's finally time to be looking at the Taramps SMART 5. Very highly anticipated amplifier, this one, especially since the success of the SMART 3. Now, no messing around, let's get straight into it, and I guarantee that you, by the end of this video, will know whether the SMART 5 is the right purchase for you and whether you should be getting the regular SMART 5 or the SMART 5 base. Now, this is not just the SMART 3 made bigger or some variation of the existing 5K amps that Taramps has to offer. The SMART 5 has been freshly designed from the ground up, which is one of the reasons why it's taken some time after the release of the SMART 3, which was essentially a clever version of the base 3K. No, Taramps has thought carefully about this amp and designed it accordingly. In past videos, I've done a really in-depth circuit overview of new amps that have been released, but I realized that the majority of people just want to know the general pros and cons and how it may affect them, rather than sitting through an hour-long analysis of the various wave shapes and behaviors. So let me start with the things that I like about this amplifier and how they'll affect its operation when you use it. The model I have here is the base version, which has some slight circuit differences to the regular SMART 5 that I'll outline a bit later in the video. But most of these points will apply to both versions. Firstly, it's important that you understand the benefits of these constant power amplifiers and why they make so much sense compared to a regular amp. Let's look at three hypothetical amplifiers here in a simplified example. A regular 8K, a regular 5K and a SMART 5K, all rated for 1 ohm operation. The regular 8K will make 8K at 1 ohm and 5K at 2 ohm. The regular 5K will make 5K at 1 ohm and 3K at 2 ohm. The SMART 5K will make 5K at 1 ohm and at 2 ohm. Now, let's connect a 1 ohm subwoofer to these amplifiers and say that it rises to 2 ohm at a given frequency. At clip point into the risen 2 ohm load, the regular 8K will deliver 5000 watts to the coil. The regular 5K will deliver 3000 watts to the coil, and the SMART 5K will deliver 5000 watts to the coil. By this example, you should be able to realize that constant power amplifiers are actually acting as much bigger amplifiers under the hood, but with a current limiter attached. The SMART 5K and regular 8K will perform exactly the same as each other in this example, despite the higher official power rating of the 8K, since you aren't able to use the available power after rise. Using either of these SMART 5K amps wired to 2 ohms though would be a bit of a waste of its abilities, since this just turns it into a regular 5K 2 ohm version amplifier, as you will always rise above the point where it can deliver its full 5K doing the smart stuff. Smart amps like this are best used on the lower end of their ohm rating, since the more that you rise above that, the more you reap the benefits of their abilities and the bigger the amplifier will feel. So the SMART 5 here immediately feels heavier and more robust than you may be used to from Taramps' past offerings. The heatsink is thick and well thinned, including on the inside where the airflow from the fans will pass, keeping the amp cooler. The plastic end trims is not too bendy and it stays in place. I've seen so many of these snapped in the past on the older models. The dual input power terminals are monstrous. First time we have seen dual inputs from Taramps in an amplifier this small. This will make for improved dynamics and power at lower impedances. The speaker terminals are much bigger than before, a welcome upgrade over the pitiful tiny things on the older HD lineup. The PCB is also very high quality with thick traces allowing for high current flow and also preventing board flex. There is a little bit, but very minimal, considering that there's no center board supports. This helps prevent vibration damage when mounted in less than optimal locations such as the subbox. The fans are controlled by audio output level and temperature, so while you have your track paused or you're just cruising around on low volume, they will not turn on and annoy you. They only spin up when the output level exceeds quite a high threshold or when the heatsink is hot enough to benefit from them. This is a welcome addition because these smaller fans have quite an annoying high-pitched tone to them. The RCA ring ground is a completely separate floating ground to the amplifier's main ground. This is super important when you're running multiple amps or different amplifiers and different brands together for bass and front speakers, as running amps together with one having floating ground and one having a common RCA ground is one of the biggest causes of that awful noise and alternator whine coming through your speakers. Older Brazilians and other cheaper Chinese amplifiers are especially bad for running the signal level ground on the RCA is common with the main ground, so this is great to see here on this SMART 5. The whole chassis is the main ground for both output and power supply sections, connected all along both sides of the board here. This allows for most of the trace area on the PCB to be taken up and used for the positive current throughput, and the case can form a large part of the ground current path. Now on the scope, although the output from each side of this amplifier may appear to be noisy or dirty, since this is a full bridge amplifier, the speaker connected only will react to differences between these two terminals. Since this amplifier has both sides perfectly matched, it produces little to no audible noise whatsoever when powered up, even through a connected tweeter, which is very sensitive. This is a problem with Class D half bridge amps, since any noise created by the output section is referenced to ground, which is naturally dead flat, allowing for the connected speaker to see a potential difference across it. With this being full bridge, Taramps can focus less on the noise reduction, which often comes at a cost of power throughput, and focus on getting the most current to your subs in the form of less filtering. I repeat, this is not an issue, not dangerous, and it will not heat your coils up. It doesn't make any difference to the subs whatsoever, since they don't actually see this noise, as it's the same on both terminals. There's no potential difference across them. Modern, low resistance, high current MOSFETs are used throughout, making for an efficient, cool and compact amplifier. The VU meter on the front is a fantastic addition. This tells you exactly how much headroom you have left in the output, showing you how far away you are from the output voltage limit and ultimately clipping. I wish all amplifiers had these. The clipping indicator itself is dead accurate to when the sine wave touches the rail and starts to distort, or when the designed current across the output section is exceeded and then the limiter activates. Taramps have come away from using one single massive transformer and instead gone with a pair of smaller transformers in the power supply, which has many reliability benefits over just using one single large one. You don't need to stress about holding high 14s with this amp, since above 12.6 volts, the rail voltage is regulated to a fixed limit, so you won't really gain any extra power beyond this point. There's a little to be said about less current being required by the power supply section at higher voltages, but the difference between the 12.6 and 14.8, for example, is only about 60 amps. Nothing to worry about with the thickness of these traces and the ratings on these MOSFETs used. All Taramps amplifiers have a health check mode built into the PIC on startup that will detect any shorts or failures before powering up with the high voltage rails, thus preventing full meltdown of the power supply section, as happens with most old Korean circuits still. Due to how these full bridge amps work, there will always be high voltage DC on both positive and negative speaker terminals during operation. However, on some brands, this voltage remains present even after powering off the amplifier until the rail capacitors have been fully drained. On this Taramps, the majority of the voltage disappears when powered down, leaving only around 12 volts. This will prevent the accidental shorting to the case that happens on some of the other brands when removing the speaker wires shortly after powering down, which kills the output MOSFETs. So good job, Taramps. So with these positives in mind, let's take a look at some of the things that are less than ideal about this amplifier. The power supply transformers have some loose winds, which is a big problem when subjected to vibration. They will move against each other and eventually rub through the laminate coating and short out, causing a lot of blown components and smoke. I suggest Taramps look at how Powerus are finishing their transformers and take note, as those things are near bomb proof. There is a huge ringing spike on the power supply MOSFET drain. This causes the power supply FETs to heat up a little, running even idle, which is extremely rare and will cause some switching losses. This is very undesirable, and I hope Taramps addresses this. It probably just needs some minor tweaks to the snubber circuit or the way that the transformers are wound. There is only one single RCA input, the other is an output. Now technically this is absolutely fine. Since this is a mono amplifier, there is absolutely no benefit to running any mono amplifier with two RCA inputs, despite what self-proclaimed experts online will tell you. However, the 12-volt industry has grown up around the basis that head units and mono amps supply and take both left and right for mono subwoofer application. Therefore, to only be able to plug one in becomes a bit of an inconvenience. Most RCAs will come as a joined pair, and you either have to leave one dangling or use a 2-to-1 wire splitter, which just adds unnecessary connection points and resistance. Many people buying this amp won't even check or realize that this is the case and hook up both RCAs from their deck into the amp and may run into problems as a result. The dials on the side are quite stiff to adjust, especially the filter dials, since two pots are ran paralleled. It's awkward on the fingers, and flatheads have to be perfectly sized or they risk rounding off the plastic slot. The notations on the low pass knob bear absolutely no resemblance to what the filter is actually doing. The minimum marked value here is 60 Hz, so you would expect to have mostly flat output at least up to about 45-50 Hz before it starts notably rolling off. The reality is that with this knob at minimum, the signal starts rolling off at anything above 20 Hz, going from 100% signal level at 20 Hz, reaching 50% of the original signal level by 40 Hz, and by the time we hit 60 Hz, we only have 25% of the original output level. In terms of power, that would be like 5K at 20 Hz, 2.5K at 40 Hz, and 1.2K at 60 Hz, with the low pass filter supposedly set at 60 Hz. In reality though, this probably isn't such a bad thing. Most users with only a little knowledge here and there will probably assume that the knobs shouldn't be left on 0 anyway, and will probably be used to running their low pass knob just beyond a third from older amps that they may have had, like Koreans and stuff like that. Turning this low pass filter up to exactly halfway on the Smart 5 gives us pretty flat output from 20 Hz until we reach 32 Hz, where it starts rolling off and 50% of the output signal level is reached by the time we get to 63 Hz. Opening the knob right up to full at a stated 200 Hz doesn't start rolling off until we get to about 140 Hz. The way that these filters are set up will actually cause the amplifier to sound extremely smooth and deep, like favouring lows, and it will probably be fine and great for most subwoofer applications, to be honest. The high pass filter seems a bit useless though. It doesn't offer barely any roll off until you get right up to the end of the knob, at which point it applies a gradual slope from around 40 Hz and under. My advice is that you forget trying to set the filters on the amp itself, simply leave the high pass filter at minimum, set the low pass filter to around 3/4 or whack it up all the way on a higher tuned bass setups, and simply use the head unit or DSP for the active filters on board. The output MOSFETs in the base model specifically are rated for an absolute maximum voltage of 150 volts. Normally when you're designing an amplifier, you'll select MOSFETs that have a bit of voltage headroom to account for spikes, bulges and ringing, and generally overall improved reliability of running them comfortably within their limits. Many of the sound digital based boards coming out of China, such as the Sundown Fullbridge, B2 Riot, GZCA, Defponts Apocalypse and so on, have some common reliability issues down to running their 200 volt FETs close to their limits at around 196 volts. Therefore, in the Smart 5 base version specifically, I have some concerns for their reliability going forward, running their output MOSFETs literally dead on their voltage breakdown limit. The regular Smart 5, the non-base version, is much better since it uses lower current but higher voltage 200 volt FETs and runs the rails at around 178 volts. It's still quite close, but it's within some breathing room. When I mentioned this to the engineers at Taramps, they said that they were working on finding a better output MOSFET for the base model that retains the same current capabilities of the 150 volt FETs it's got in it now, but with a higher breakdown voltage. So hopefully this will be implemented, since as it stands, I predict some people having some random failures with the base version as a result of this. I may be proven wrong though, especially if the IRFB 4115s here are spec'd up with some voltage headroom above where they're officially rated on the datasheet. Saying this, the output MOSFETs do run hot at idle, and they run unevenly hot. This is often as a result of running them too close to their voltage limits and small variances in the silicon, or insufficient dead time between the gate drive pulses, or badly matched FETs from manufacturing. What this means for you as the user is that if it's enough to cause an issue, you may have hit and miss experience depending on whether you get a good one or a bad one with how the FETs are matched or how good the silicon is. The gain knob is very sensitive and jerky feeling. At its minimum position, it appears to be running a specifically set 4V input mode that should bring the amp to a back clip point pretty much as the 4V mark is reached on the signal. As soon as you turn the knob away from minimum position though, it seems to switch instantly to like a different mode, jumping up considerably at first and then following a linear curve upwards. It's worth bearing that in mind. As with almost all Brazilian amplifiers, the heatsink, the case, is full main ground for the output section and the power supply section. So never disconnect or connect any speaker wires while the amp is powered up, even with nothing playing, and don't let the 12 volt power wire touch the case. And take extra care when you're screwing it into anything metal, etc. Make sure that nothing is grounding out anywhere that it shouldn't be on the case. So with that out of the way, I'm sure most of you are wondering what the differences are between the regular Smart 5 and the base version. I was originally going to have both versions here to compare and review for you, but sadly the regular model was out of stock at the time. However, I can still give you all the information you need to make the right purchase. First of all, straight off the bat, the regular Smart 5 will be louder. The internal rail voltage of the regular Smart 5 is higher, therefore giving you more output voltage before it reaches clip point. The two amps are literally 95% identical. They share the exact same PCB as each other, apart from different preamp filters on the base version and a lower rail voltage in the base model to count for the 0.5 ohm stability. So unless you're going to be wiring to 0.5 ohm or lower, and you know that you don't really have much impedance rise, or you don't really know what you're doing, the regular Smart 5 will be the better choice for you, due to A, being more powerful, and B, having more voltage headroom on the output MOSFET, so it should be a little bit more reliable. Just make sure though that you set the preamp filters actively to get that nice smooth bass sound that you want, similar to how you might be used to with the Koreans and stuff like that. In my opinion, the only time that you would want to use the base version is if you're wiring to 0.5, you don't really know what you're doing, and you want to make sure that you don't kill anything, or you know that your rise is very poor and you want to play it safe. So I think I covered everything that I wanted to talk about in this video. Now, if you watched my Digital Designs M4000 video, you know that in that one I put the amplifier in the van and see how it sounds. And I want to do that with the Base 5, but it's just not stopped raining for like a week, 2 weeks. I need to get this video out as soon as possible, and for me to kind of wait for a nice day to like go and show you, because basically in the van I'm running a HD 10K, a super old one at 0.5 ohms. Wow, yeah, crazy, but I have a lot of high rise, so it's absolutely fine. It runs really cool. So I thought that would be a great opportunity to put the Smart 5 base in the van instead of the HD 10K at 0.5 and just see how much of a difference it is. I think that the Smart 5 base will act like it'll probably act or sound like a sort of 12K, I reckon. With the HD 10K in there at the moment, a 0.5, with the amount of rise I have, it's quite equivalent to if I was running a 20K amplifier in there. So I think that because my system is maximum, it's excursion limited, like my subs reach their excursion limit before like the amps clip or before my power supply runs out or anything like that. So I'm limited by my subs excursion. So I don't think there's going to be much difference between the HD 10K at 0.5 and the Smart 5 base at 0.5. So that'd be interesting to see, do some dB runs and measure the difference between the two amps and how they sound, especially with those bloody filters on that Smart 5. But yeah, guys, thanks for watching. I'm chilling in my dining room in my new house, love it. I've just done this brick wall. These are brick slips, so these aren't actually bricks, they're just like little tiles you put on the wall. And I've got to finish these off, got to do some pointing in between. As you can see, it's just tile adhesive at the moment, so got to finish that off, do some coving as well at the top there. But anyway, thanks for watching, and I'll see you guys in the next one.